But first of all, welcome. Thanks for coming today. I appreciate you taking some time today to be here to discuss this project and to give us your impressions of these experimental wines. Just so that you know, you are sort of being recorded today, so just be aware of that. I'll start just by giving a little bit of an update on what's going on with WRE right now. Basically, most of the time, usually we would be done with our sensory sessions right now and be moving into that point of the year where we look at experiments for next year. I thought this was going to be the last sensory experiment, and I think I might have told you last time there was one more that was maybe hanging around, and I tasted those wines with Mathieu a couple of weeks ago. And basically, Mathieu and I sat around and talked about them for about an hour. And I felt like if there was that much for us to say about them, then it was worth sharing those with you as well. So we will have one more of these virtual sessions in July. And again, we understand that we're kind of getting into that period of time where you're busy in the vineyard, where you might have other things going on that you're not usually in your office. But if you're able to make it, we would love to be able to share that information and that experiment with you as well. So we haven't scheduled a date for it yet. I'm hoping to have a date for that in the next week or so. I will also be rolling out a newsletter with all the information from today, kind of in written form and with some more background information. So hopefully we'll have a date by then, so you can keep an eye out for that. But really, it is time to start thinking about experiments for next year. I realize it's a very unusual year in all kinds of ways, but there still are some good experiments to be done out there. So I'm just going to kind of issue an open invitation right now to start considering what are the things that you would be interested either in running as an experiment yourself or in seeing somebody run through the WRE. I will give kind of at the end of our time today, I'll give you kind of a review of what we've found out in the things that we've been doing in the last year or two. Hopefully, first of all, just to make sure that you have that information before you go into your winemaking plans for next year, but also hopefully to get us thinking about what are the continuing questions we want to be working on and what are the new questions we want to start looking at. So that we'll do that toward the end again, hopefully as a way of getting you to think about whether you would like to do some experiments and what kinds of experiments you would like to be attempting. So just a couple of logistical things before we start going here. We are sort of in the meeting format, so that means you have control of your own microphone, and we do that on purpose. We would really love to encourage you to participate in discussion. If you have a question or a comment that you would like to add, please feel free to unmute yourself and add your voice to the discussion. I do ask that when you're not actively participating in the discussion, you keep your microphone muted, just so that we can cut back on the ambient noise that happens in whatever environment you're in and whatever environment I'm in. And then the other thing is you do sort of have a chat button at the bottom of your screen. If you click on that, you should be able to see the big old chat box there. I will try to be monitoring the chat box as we go through the day today. Sometimes when I have my slides up, I can't see the chat box as well, but I think I figured out how to do that, so we'll see how that works today. But you can always sort of put a comment or a question in there, and hopefully I'll come back to it. If we're sort of in the middle of talking about something, we can maybe come back to that. So if you don't want to just verbally speak up, you can always put something in the chat. And so by way of sort of introducing ourselves, why don't we go ahead and use that chat box on the bottom to introduce ourselves. That way we can just say who you are and what winery or vineyard or company you're representing right now. That helps us to get an idea of who all is here. Sometimes your screen names tell me that, but sometimes your screen names don't. So, and as you guys are doing that, I'm also going to put two things into the chat box, and those are PDFs of the two different studies we're going to be looking at today. So we're going to review some work that Kirsty did in 2018 and look at her new work from 2019. So I'll put both of those in there in case you want some additional details on those as well. And I have to figure out how to do that. Let's see, there we go. Okay, there we go. Okay. All right. Okay, so welcome again, everybody, and thank you for being here. So, as I gave you this very ambiguous title of SO2 management. Some of you that were here to see some of Kirsty's work last year have an idea of what this is all about. But we're just going to start with a couple of just a little bit of review about SO2, just so that we're all on the same page with some of the issues that we're going to be talking about. Then I'll have Kirsty come in and talk through both her work from 2018, which sets us up for her work from 2019, and those are the experiments that you just tasted for this. So, I think when I was thinking about how to get all of this started, I thought maybe we would just start with this idea of one of my favorite things to find on a wine bottle is when it says it has minimal effective sulfur. I don't know about you guys, but when I see that, I kind of feel like, what the heck does that mean, right? What is minimal effective sulfur supposed to? It's such an ambiguous term, and we probably all have different ideas of what that means. So I thought maybe we would actually start with a quick little discussion amongst ourselves about two of the terms there. So first of all, the effective term. When we're thinking about the effects of SO2, when you're using SO2, what effects are you looking for? So this is where I'm going to invite you to unmute yourself and just call out some of the reasons. If you use SO2 in your winemaking, which I'm assuming most of you do, what are you using it for? Why are you adding SO2 at any given point? I will start calling on people, so go ahead and unmute yourselves. What's the SO2 for? Why do we even use it?
It's an antioxidant.
Okay, it's a good antioxidant. Why do we want to be antioxidant? What's the effect of oxidation that we're trying to prevent?
Well, one of the things you can do is stabilize color.
Okay, so we want to stabilize color, not lose the color to oxidation. Okay. Other effects of SO2?
Antimicrobial.
Okay, antimicrobial. So what microbes are we trying to fight with SO2?
Acetic acid bacteria.
Okay, so Brettanomyces, acetic acid bacteria, which cause those foliage, flavors that we don't like, off odors, and volatile acidity. Other effects of SO2. If I don't add SO2, what does my wine smell or taste like or look like? I see lots of smiles out there. Pipe up. What are the code words for those wines that don't have SO2 in them?
Some people would say the code words of those wines have longer, have a greater longevity.
Okay.
That's kind of the interesting thing about this whole topic, because I have tasted some wines that are 7, 8 years old without SO2 compared to wines that had SO2, and those wines are definitely different. And they're not always better, but they can be, and frequently are. But there's a couple of caveats, however. The fact that SO2 wasn't added doesn't mean that there wasn't any SO2 in there, of course.
Right.
And of course, you've got a lot, these are red wines we're talking about, so they have a lot of antioxidant buffers, so that even in the absence of SO2, you get plenty of antioxidant activity.
I think my experience with low SO2 wines or wines that have not had a lot of sulfites added to them is generally not a positive. I've generally find more negatives and more faults in those styles of wines. Perhaps maybe I'm not trying the right wines, but my experience with low or no sulfur generally has led me to be disappointed rather than impressed with those wines.
Yeah, in our environment, I'd say that's a little bit sketchy. The wines I've tasted have been West Coast.
Okay, so let's go back to minimal. So if we are adding SO2, why don't we add so much SO2? Like, why don't we just bomb the thing so that we can kill all the microbes and get rid of all the oxygen? Why would we want to think about that minimal piece of effective oxygen or effective sulfur dioxide?
Because you poison people.
And
well,
you're- and-
probably not at
and you
least. If you're within the legal limits, you're probably not poisoning.
And you shut down the aromatics a lot of times if you use too much.
Okay, so you can have some shutting down of the aromatics. It can start to mute the aromatics. Okay, other things with having a lot of SO2?
You would limit the phenolic polymerization and therefore the ability to stabilize color and have your wines evolve.
Okay, so it can have some interference with phenolic polymerization and the phenolics binding to anthocyanin
and tannin binding.
Right. Yeah.
There's a bleaching effect with the rosé and those really light reds that happens.
Yeah, so those light reds in rosé that don't have a lot of tannins to bind to our anthocyanins, some of that SO2 can cause bleaching. Anything else?
There is a legal limit on it.
Yep.
350 or so ppm total SO2.
Yeah, the legal limit is so far above anybody's standard use. So it's interesting you mention that, because I ask winemakers, sometimes they don't even know that there's a legal limit because they don't add anything near that.
Right. So yeah, but there is a legal limit, and I think that goes back to what Rick was saying. At some point, we do start to, I'm not sure we're poisoning people, but you would start to see some real adverse effects, both in flavor, but also that's when you might get into some argument of, having some effect on people's perception of the wine, either getting headaches or that sort of thing. At the levels we use, that's really not much of the case. So, okay, so at this point, I'm going to go ahead and share my screen. I'll show you some of the things that I've just sort of the list that I found when I looked in the literature of some of the things that we might be thinking about with minimal effective sulfur. Let's see if I can do this. Yeah. Okay, does that look about right? Okay, so with minimal effective sulfur, some of the effects that we might be looking at, and you guys touched on most of this, is really preserving freshness and fruit character by preventing oxidation. So we talked about being antioxidant. And a lot of times if things get oxidized, we lose the freshness of the wine or we lose some of the fruit flavor to that. Another effect of using SO2 is really to kind of diminish the kind of nutty flavor that you would get from a lot of acetaldehyde in the wine. So your SO2, particularly like right after you're kind of finished with fermentation, if you have that kind of nutty thing, once you add your SO2, it sort of diminishes that. It turns that into a non-perceptible flavor. I think this came out, it can actually, if you add SO2 early on during maceration, it can actually help extract some color from the skins. And then eventually it can help prevent browning as part of that antioxidant effect as well. We brought up microbial spoilage. We talked about Brettanomyces and acetic acid bacteria early on in fermentation that can also help to control clochera and cut down on ethyl acetate production. And if you want to keep your white wines from going through mallow, sulfur is a way to do that. So sulfur, malolactic bacteria are sensitive to sulfur dioxide. So if that's an effect that you want to keep them from going through mallow, that would also potentially be an effect. And then some of the reasons to minimize, the reasons not to just bomb things. You guys really hit on all of these, is the potential of bleaching in our anthocyanins, although there's some idea that it actually sort of can help to prevent oxidation of some of the anthocyanins as well, and we'll get back to that in a little bit. Bruce spoke about tannin polymerization, and the sulfur basically would bind in the same place that tannins would be polymerizing and could be blocking that. And then sometimes if you have a lot of sulfur, particularly a lot of free molecular sulfur, you can actually sort of detect some off odors just from the sulfur itself, in addition to tamping down the fruit or the intensity of the wine. So sometimes when you do that first add and you have a lot of molecular in there, you kind of get that weird burnt match kind of thing, and that can be a bad effect as well. Okay, so when you're deciding what your effective sulfur add is, and we can get away from the minimal effective part entirely, but how much are you adding? So what I'd like to do is basically take a quick survey in the chat box, and we're just going to focus on the end of malolactic fermentation in red wines. So when your red wine is done with mallow, how much SO2 are you adding in that initial add right after ML is done? And maybe if you want to tell me one, like what's your goal in doing that? So if you're going more for an antioxidant effect or an antimicrobial effect, or if there's something that's sort of driving that decision. So go ahead and put that into the chat box. I see a couple of those coming up.
Well, it should be a function of pH.
Okay, so pH does have a role to play for sure. And we're actually going to look at that in a little bit more detail in just a minute. So yeah, and again, just thinking about your maybe we'll think about kind of where our average red wines are when you're finishing. Okay. You guys are a little bit on the higher ends. All right. Anybody adding less than, I think what I see in the chat box right now goes like in the 40 to 50. Oh, I have a 30. Okay. 40 to 50. Okay, so we actually took a quick little survey of this last year when we put this in for, when we did our first tasting of these wines. When we did this survey last year, how come I'm not advancing? There we go. About 70% of people who responded, we only had about 10 respondents, but 70% of those said somewhere between about 25 and 50, and you guys are pretty much in that category as well. Whereas we had about 30% of people were sort of in this larger ad of 50 to 75. And we started to ask, you know, when we asked the follow-up question, what determines that rate for you? Why did you decide to do this at 40 or at 35 or at 50 or whatever? Many of the things that we've sort of talked about came up. So the idea of ageability being something that has to do both with oxidation, deterring spoilage, and preventing VA accumulation. So allowing the ageability of the wine that way. And also, as Bruce was mentioning, sort of thinking about ageability in terms of structuring tannins. And again, to achieve a specific target, that target is probably determined by those other things. What are we trying to achieve with it? And again, pH has a role to play, which we'll look at in just a second. This one was my favorite response, though, to keep the wine safe. And I would think that, yes, we want to keep the wine safe during aging. But the question is how do we decide what that target is for that first ad to set ourselves up to be accomplishing what we want to be accomplishing with that SO2 addition as we go forward? So, you know, the first thing I'm going to do is, and this slide is for me more than anyone else on the call today, because I am very sloppy with my terms. And so this is to remind me to tighten up the way that I talk about this. So when we sort of read wine literature, there's a lot of words that have sulfur in them. And so I'm just going to go through the three main categories so that I say the right words as we're talking through, but also if there's any clarification to make, that it's that we know that we're all on the same page. So sulfur itself is just an element on the periodic table. It's any atom that has 16 protons and 16 electrons. But basically it can sort of then bind with other molecules to fill out its valence shell. It basically needs to bind, so it kind of has 2 more electrons in its orbit to be stable. Now, when it makes those bonds, it can bond in one of 2 ways. If it bonds with another element, that basically means that the bonded electrons spend more time around the sulfur atom than they do around the other atoms. We call that a reduced sulfur compound. And anytime we have reduced sulfur compounds, we're talking about sulfides. When we think about sulfides in wines, reduced sulfur compounds, usually they're bonded to hydrogens. And there are usually we're thinking about things like hydrogen sulfide and mercaptans, these things that have some off odors like rotten eggs or skunk or cabbage or onion. Those are our reduced sulfur compounds. But lest we just decide to oxygenate everything to keep everything from being reduced, we need to remember that a lot of our varietal character, a lot of our nice aroma compounds are also actually reduced compounds, and some of them are reduced sulfur compounds, such as the thiols. So, you know, those grapefruit and boxwood and passion fruit that we like in some of our aromatic whites. And we even have some thiols in rosés and in some of our red wines. And so reduced sulfur compounds are not all bad. It's just when we perceive them, sometimes they're on the edge to give us an indication it's time to do something along the way. But if sulfur is binding in a way that the oxygen basically, or I'm sorry, the bonded electrons spend more time with the other bonded atom, then that's an oxidized sulfur compound, and that's when we're talking about sulfites. And the primary sort of oxygen hog in the bonding world, or a electron hog in the bonding world, is oxygen. So when sulfur is bonded to oxygen, as it is in sulfur dioxide, then that's an oxidized sulfur compound, and it's a sulfite. So I will try to be good about using those terms appropriately as we move forward. So the other thing, when we're thinking about sort of how do we manage SO2 in our aging red wines, we need to remember that SO2 doesn't stay in one form is when we put it in the wine. So as soon as that SO2 gets into the wine, our wine is 85 to 90% water. So that SO2 is interacting with water to take on different forms. Some of it is in what we think of as the molecular sulfur form, the molecular sulfur dioxide form, but some of it will interact with an oxygen and a hydrogen from that water to form the bisulfite anion. And then some of it will actually give up one more hydrogen there and form the sulfite bianion. So it's got two negative charges to it. We have to remember that this is always sort of in dynamic equilibrium. So there's a fixed proportion of any one of these components based on the pH of the wine. So if we look at where our wine pH normally is between 3 and 4, we can see that we sort of have this proportion of somewhere between about 94 and 98% of that is actually in the bisulfite form. And the remainder of that is mostly in the molecular sulfur dioxide form. We have very little of that sulfite bianion. But what we need to, again, that idea of dynamic equilibrium means that even if the bisulfite binds to something, the molecular sulfur dioxide is going to sort of shift over to make up that difference. And so if we're at a particular pH, let's say that has 96% bisulfite and 6% molecular sulfur, if some of the bisulfite bonds, some of the molecular sulfur is then going to interact with the water, so that we're going to maintain that 6%, 96%. So you don't get to keep your molecular when you're binding up your bisulfite. That's the take-home message there. So the reason we care about that is that these different components have sort of different roles to play in what we're trying to get from our SO2. So for example, it's the molecular sulfur dioxide that has our primary antimicrobial function. So if you're trying to use SO2 to fight microbes, you really care about the molecular sulfur portion of that. And that's really because the molecular sulfur dioxide is not charged, and so it's actually able to get into the cell membranes. The other two components are charged and they can't enter cells, and so they can't get in there to sort of wreak havoc on the molecular mechanisms of what's going on inside of that cell. So when we think there is a little bit of an antioxidant effect with molecular sulfur dioxide, but again, our bisulfite is going to give us most of that. We also need to remember with molecular sulfur, that's actually the one that's volatile. So if you smell SO2, that's probably the molecular form. And you can also lose some just by volatilizing off. And so it's one of the ways that we can lose SO2. The bisulfite form, by contrast, doesn't really have much antimicrobial activity. It does scavenge thymine a little bit, which can starve some of the cells, but it doesn't kill them or inhibit them the way that our molecular does. The one place antimicrobial is, we need to remember that bisulfite does still have some effect against malolactic bacteria. So malolactic bacteria will eventually sort of consume some acetaldehyde and release some bisulfite. And it turns out that that means that our total sulfur number actually matters for the ability to complete malolactic fermentation. So if you're having trouble completing malo, checking your total sulfur is a good idea, because that might be one of the things that's inhibiting. But the primary role for our bisulfite is antioxidant. And it works in a lot of different ways, but two of the important ones are, first of all, it sort of works in the browning cascade by binding to phenolics so that they don't get brown. But one of the most important things that bisulfite does is it binds to the enzymes that makes the oxidative cascades go faster. And so when you're adding SO2, for example, to your juice, one of the reasons your juice is sort of not as brown if you add SO2, and it's more brown if you do, is because of the way it's working on those enzymes. But we also have to remember that our bisulfite is the one that's going to be binding with most of the things in the wine. So our bound fraction of our free versus total SO2 is mostly going to be that bisulfite. So if we look at what that if we sort of take a step back on that, then when you're measuring free sulfur, you're measuring any of the molecular sulfur, bisulfite, or sulfite anion that's free in solution. But then there's this whole other fraction that's bound up. So when you measure total sulfur, you get all of that. But when you measure free sulfur, it's just that portion that hasn't bound. And it's really only the free portion that's going to be giving you antimicrobial and antioxidant properties, with that exception of the total sulfur for malolactic. So you have to remember when you're doing a sulfur add, again, getting back to what's the minimum effective sulfur that I'm going to be adding, you have to remember that however much you're adding, some of that is going to bind up and basically not be effective for your antioxidant or antimicrobial properties. So there's a couple of rules of thumb that I found when I was looking through the literature. And they basically said that 30 to 50% of the sulfur that you're adding is going to end up as free, and the rest of it's going to bind up. Now, the amount that's going to bind up is really dependent on where you are in the life of the wine. So how much has already been bound? The primary things that are binding your SO2 are sugar, if there is sugar, acetaldehyde, which is just a byproduct of fermentation and also can accumulate during aging, and then phenolic compounds. So if you're early on in the life of your wine and you haven't bound those things up yet, you're not going to get as much free out of the add that you're doing. If you're sort of 5 or 6 months into that, you might get more free out of whatever add that you make. And if it's super important for you to know what that number is, like how much my free is, for example, if you're trying to manage aging for sparkling wine, or if you're trying to sort of get ready for bottling and fine tuning, somewhere between 3 and 5 days is how long it kind of takes to bind up all the stuff in there. So if you do an add and you really want to know, did I get what I needed there, wait about 5 days and check it again, and you should get a pretty good number. A couple of other quick rules of thumb. It's pretty normal to lose about 5 parts per million per month in well-topped barrels with good bungs in them. So if you're kind of trying to say, what's the, if I'm here and I need to bottle here, like how long do I have to get there? Again, rule of thumb, if nothing else is happening in those barrels, about five parts per. But then anytime you move the wine around, you're introducing oxygen, which is going to start to give you some things to bind to. And so you're going to be losing SO2 as that binds to things. So about 8 to 10 parts sort of for that whole pre-bottling process. So racking and filtering and all of those things, you probably are going to end up having about 8 to 10 parts of a loss along the way. So with all of that, what's our target, right? How do we know how much to actually add to be antimicrobial or antioxidant? And when I got ready for this, for looking at Kirsty's experiments last year, I kind of just found everything I could find in the literature, and I made a big, massive table of it. And at some point I'll drop that into the chat box as well, so that you guys can have that. I've given a little one version of it here. But when we're thinking about antimicrobial targets, let's say we want to manage our red wine against Brettanomyces during aging. If you look at the table here, it'll say we have this inhibition of Brettanomyces at 0.3 molecular, but then the biocidal effect on Brettanomyces at 0.5 to 0.8. So one thing we need to remember is you might be able to slow it down at about 0.3, but if you really want to start like having some sort of lethal effect on those cells, you need to get a little higher than that. The other problem here is that we have this big range, right? What's 0.5 versus 0.8? If we look at how much free sulfur we'd have to carry for that, that's a really big difference. So we need to realize that with microbial targets, we're dealing with living organisms. They have genetic diversity to them, and they don't all have the same susceptibility. They also adapt over time, and they even evolve over time. So we need to realize when we're thinking about that target that there's a number of things that go into there. We can't really do much about which species we have to deal with, but that might affect its susceptibility to SO2. The stage in development, it turns out that they're more susceptible to SO2 early on and less susceptible later on. So that's probably due to either some adaptation or just some selection for the more resistant strains. And then pH itself matters in addition to just what it means for how much molecular you have. it also has something to do with just the overall stress on the organism. So low pH environments are stressful for organisms anyways. So if you give it the stress of low pH and you give it the stress of SO2, it's more likely to be effective than if it doesn't have that low pH stress. So that means that when we get into these higher pHs on our red wines, we sort of have the double whammy of high pH. The antioxidant targets, basically, if you're sort of managing to keep a certain molecular for any antimicrobial purpose, you're probably already meeting your antioxidant targets. But I did put some specific antioxidant targets that I found in the literature for red wines and white wines and sweet wines in that cheat sheet. So again, I'll drop that in the chat here, and I'll put it in the newsletter and on the website. So you can take a look at what the literature says for those sorts of things. So just a couple more things of practicality before we jump into Kirsty's experiments. One is thinking, if we're trying to achieve a particular target that we've decided, I want such and so molecular target so that I can combat Brettanomyces, we have to kind of realize what that practically means in our winery. So again, when we did this last year, we put out a survey there to say, how often are you checking your sulfur? And basically with the idea of what's happening in the in-between spaces. So most people are checking once a month. Some people are checking every 2 months or every 3 months. And if you're sort of in that stage where you've got a lot more time in between, it's more and more important that you find out if you've hit your target before you sort of let it go for a couple of months, because you may end up having several months where you really aren't where you think you are and you're in more danger than you think. And then the other thing that we looked at was just what's your methodology for checking that and being aware of the pros and cons of the method that you're using. So most people are using either the Ripper method or the aeration oxidation method. And it's just important to realize that each one of them has an error rate that's inherent to the test. It has nothing to do with whether you're good at doing them or not. But the Ripper does have a larger error rate. I think it's on the order of about 7 parts per million plus or minus. So thinking again, if there's a target you really want to reach, realizing that your test may have that error rate to it. AO, I think, is between 3 and 4. But there's an additional wrinkle with AO that the way the test works, adding that big acid, basically when you do AO, you're adding acid to it to try to volatilize the SO2 to get it up into the titrator on the top. When you do that, you can actually release some of the bound SO2, the SO2 that's bound to phenolics in the red wine, and get an artificially high number. And unfortunately, we don't know exactly how artificially high that is. It depends on how much SO2 you have bound to your phenolics. So just realizing again that AO number that you're getting might be higher than what the actual SO2 is in your solution. So then the one last practical thing that we'll get to before we jump into Kirsty's experiment is how you are actually adding your SO2. And this is something that came up in conversation actually with Kirsty the other day. So Kirsty, I'm going to invite you at this point to unmute yourself and talk to us a little bit about how you're adding your SO2 and why you've changed that from how you used to be adding your SO2.
Yeah, so I used to just buy KMBS and make it up into solution and then add that to each barrel or anything that I was adding. And that was my general way of adding SO2. But then I realized, and perhaps it took me a couple years to realize it, that if you're not stirring the barrels after addition, you're really not getting that, that SO2 into the wine as you expect you would. So I think it was I tried also the tablets, but 2 years ago, I decided to change to Ephragram in order to know that when I'm adding it, I do get some mixing action because of the way that Ephragram works. And I thought that the time saved, and actually just introduction of a stirring rod into the barrels, the time saved was worth the additional cost. So I switched from KMBS to Ephragram for most additions that are not during harvest. During harvest, I'll still add KMBS into solution, but once it's in barrels or tank, I'm using Ephragram.
And for those of you that haven't used the Ephragram tablets, I hadn't used them, Kirsty, until I worked in your cellar for a little bit. But basically, they're these little tablets that kind of look like a little Pepto-Bismol or something. Like you put them in there, and they just start to sort of bubble and dissolve. Is that good?
Actually, those are the Onosterol tabs. The Ephragram is actually it looks like Pop Rocks for those of you that know Pop Rocks from years ago. So it is actually just those little pieces that then fizz. I've used both, and I found that sometimes when I use the Ephragram tab, when I racked the barrel at the end, that tab was still there. So that's why I actually went from KMBS to the onosterol tabs to then to Afragran powder.
Okay. Yeah, so whatever, and another wrinkle to this, Emily Pelton has shared in the past that she uses the liquid SO2, so basically bubbling SO2 into water to get liquid SO2 and doing the addition. But it's important if you're doing that you remember that that's more dense than your wine. So if you just add it in, it will sort of go and pool on the bottom. And it'll look like you didn't get very much left. So you may end up having, first of all, you don't have protection, but then you do your next you do your next measurement and it looks like you don't have very much SO2 and you do another add, and really it's kind of pooling at the bottom and you end up over adding that way. So again, just that importance of getting good mixing on it, or making sure that whatever you've added in there is all the way dissolved. And it seems like just this very practical thing, but it can be very important if you're trying, again, to get an effect out of what you're doing. So with all of that then, Kirsty, going into 2018, you knew all of those things ahead of time. You went to wine school, you know all the things about SO2, but you wanted to do this sort of series of experiments looking at SO2 management in your red wine. So tell us a little bit about what the questions that you were trying to answer and the approach that you took to that.
Yeah, so my original level of addition after post-malolactic fermentation was 30 parts, so 30 milligrams per liter. And then my best intention has always been to check SO2s once a month. Somehow that doesn't always work out. So I was finding myself having more and more time between addition and then checking again. And I always notice that I'm adding 30 parts, but by the time I get around to checking, it's almost nothing. So it challenged me to think, okay, well, instead of having a 30-part initial add, what if I increase that addition to something quite a bit higher? So I went with 75, and then was reading in the literature, and I think in talking to you, Joy, we sort of saw that some of the literature was saying that if you wait 2 weeks after malolactic fermentation is finished, you actually have the benefit of the malolactic bacteria consuming some of the acetaldehyde that might be in your wines. And so a delay in addition might actually serve you better in having more of the SO2 that you're adding stay as free SO2 and not bound. Does that make sense? So we set up the experiment in 2018 in a few different ways. We had a low dose, which was the 30 milligrams, and the high dose, which was 75. And we did that addition directly after malolactic was finished. And then we chose to delay that by 2 weeks. And then I had neutral barrels and new barrels. So there's lots of layers to this experiment. But the basic question was, does that higher initial dose have any effect or any impact? And is that impact positive?
So really this started with a very practical management question of how to keep your wine safe for this period of time. That was the practical amount of time that you were having to go between sulfur additions. And I think, a lot of folks are in a similar situation as Kirsty, in that you're really the primary one doing all of the work. And if that includes work in the cellar, if that includes doing management work, if that includes work in the vineyard and that sort of thing, sometimes you do have these periods of time where you're not able to get at your barrels to do your monitoring, to do your additions. And I think this becomes particularly important right now, because we're sort of in this era where we may have times, for example, where people are furloughed, with the cellar staff has to stay distanced from one another, that sort of thing. And right now it looks like that might be happening periodically through the next season of our winery life. And so thinking about a strategy that just allows that to actually hit the target and do the thing that you're looking for it to do. So as Kirsty said, there were basically 3 pairs of barrels in this experiment. So there was one pair that got that was a neutral barrel, both neutral barrels, both sort of neutral but from the same source, and they had come into Kirsty's winery from the same place at the same time. So trying to be as comparable with these barrels as possible. So one that got a 30-part add, one that got a 70-part add, pretty much as soon as Kirsty knew that they have finished malolactic. And she is able to determine that in-house with a spectrophotometer. So she gets to that determination pretty quickly. Another set was basically the same situation, but in 2 new barrels in 2018. And then another one where there was that delay after, okay, it's malic negative now, I'll wait a couple of weeks and then add the SO2. And then throughout the year, basically what she did is she would test her her free sulfurs, and then she would do whatever addition that she would normally do with that free sulfur level. And I think the target here was just to maintain a molecular sulfur of 0.5. And that seemed to be what you could, and Kirsty, do you want to talk a little bit about why 0.5?
Yeah, 0.5, because I mean, I knew from wine school that SO2 is pH dependent, and that 0.8 is what you need for better effect on Brett, but often pHs in our area, basically, I didn't feel comfortable going so high molecular with the pHs in the range of 3.6 and 3.7. So I sort of settled on a molecular of 0.5, and I kind of looked at that chart that you had and looked like, it seemed like I was hitting some of the targets for different microbes, and I felt that 0.5 seems like a reasonable amount to try and keep throughout the aging process. So it wasn't any grand thing other than it seemed like a good level.
Okay. And if you're wondering, like, how do I know what my molecular is? There are charts that are available in most of the wine textbooks, but I personally just go to Wineads, so www.wineads.com. Under the SO2 tab, there's a place where you can choose molecular, and you can put in your pH, and you can put in your target molecular, and it will tell you what your free sulfur should be at that pH to get that molecular. It will actually calculate the ad for you if you're in the process of doing those ads. So, okay, so with that set up, a couple of things with the results here. So this is just the high versus low in the neutral barrels. If we look at that high level, we can see that initially we were above the 0.5 target, but then over time, even within, you know, somewhere around December, January, it had sort of drifted down to be below that 0.5 target. But no, and then you can see there was an addition then that happened. I think there was an addition then, and then there was another addition in March. But most of the time, even with 70 parts as the main addition, Kirsty was still aging mostly below the 0.5 target. But if you contrast that to what's happening with the 30 parts, the 70 parts got you closer to the 0.5 target for sure. And it really basically, you were kind of trying to catch up the whole rest of the year with these SO2 additions when you only started with 30 parts. And so that 30 part ad really wasn't doing the job in the beginning. And even with monitoring and additions, it just sort of took a lot to get back up there. And you can see from this chart also that that did lead to higher total sulfurs in the high ad, but again, we have to take that with the understanding that we never hit the target. So it was lower, but it wasn't at the target. So then the next thing that we looked at was that Kirsty looked at was whether it helped to delay or not. So again, this is just looking at I think this is looking at the 70 part ad on time and delayed. And we can see that the delay, it sort of follows the same path, but we did have slightly less binding. She did have slightly more free sulfur in the one that had that delay. And again, as Kirsty brought up, the whole reason for this delay really has to do with the effect of acetaldehyde. So acetaldehyde is just made by your yeast during the course of fermentation. So everyone's going to have acetaldehyde at the end of fermentation. I will say that one of the things I found in the literature is that one of the ways to decrease your acetaldehyde and therefore decrease the binding of your SO2 is how much sulfur you're adding at crush, because sulfur is going to be toxic to yeast in a certain way. And one of the ways that they detoxify is they make acetaldehyde to try to bind it up. So if you're adding more SO2 at crush, you're producing more acetaldehyde through that process, and you might have a little bit more binding. But as Kirsty brought up, basically another way to reduce that is to let things go through full mallow and let the malic acid bacteria consume the acetaldehyde at the end of malolactic fermentation. They do that along with diacetyl as well. So if you don't like diacetyl, full mallow and a little bit of time afterwards might get you there. But the other thing with acetaldehyde, again, is that it also can be formed through the oxidation of ethanol. So it can also sort of just keep forming through aging if you've got oxygen in your wine at some point. So you are going to have some binding that continues to happen. So this sort of delay only really works on that one constituent of it. So again, so if we look here, we can see that we do kind of get that. And if you look at the total here, we got better binding, we were closer to the target, and we actually had lower total sulfur with that particular approach. So then, but it actually, we have that question of what's that doing to the phenolics? What's that doing sort of to the phenolics overall? And what's that doing to our perception of those phenolics? So we did measure the total anthocyanins. We had some more fine-grained information on anthocyanins that are in the report. But it actually looks like overall having adequate sulfur dioxide throughout aging basically helped maintain some of the anthocyanins in the solution. So probably they were just less likely to get oxidized and be lost. So we did have slightly higher anthocyanins. I believe the color was a little bit lower, so that might be that they're there, but they're a little bit bleached. But it is in our higher dose barrels, we did seem to have more retention of anthocyanins than in the low barrels. The tannins had sort of no discernible pattern in terms of that, just that main sort of total tannin number. But again, tannin polymerization is a different thing than the total tannin that you have. So we may have had some effect on the evolution there that we're just not able to pick up with this particular test. But I think the most important thing was basically what the sensory on this was. So Kirsty, we tasted this at 2 different tastings, and in both cases we tasted high versus low, and we tasted on time versus delay. So, you know, from your perspective, what was the take home for you in terms of what that meant for sensory?
I generally liked the higher dose delayed barrels. I don't remember if I got it perfectly right each time, but I felt like every time I thought about those wines and dealt with those wines, the ones that I liked better and seemed fresher to me was the higher dose with the 2-week delay.
So was it primarily the freshness that you thought was different between them, or were there other things that also came out for you?
I think it was mostly the freshness. Perhaps some of the fruit qualities were different. The higher dosed delayed barrels just tasted, fresher, cleaner in some ways to me, a little bit less muted.
Okay. When we look at sort of the overall impressions from those, again, we tasted them at 2 different tastings, and one had sort of a small number of people, so we weren't able to run the statistics on all of them. But when we compared the high versus low in the triangle test for both of those tastings, the wines were significantly different. People were able to tell the difference between the 2 wines at both tastings. At the first, and the fruit intensity was rated higher at one of the 2 sessions. In the other session, we just didn't have enough numbers to be able to run that statistic very well. So we did, and again, these are small differences in fruit intensity, but they were statistically significant in one of those 2 tastings. And then the normal versus delay were also significantly different. People were able to tell the difference in a triangle test. And again, none of the descriptors were consistently different at all at both tastings, but at least at one tasting, aromatic intensity and fruit intensity were rated higher in the delay than in the non-delay. Again, at one of those tastings, though then we had a little bit better numbers for. So that's pretty much in line with kind of what you were saying. But then we did sort of have them sort of taste all 4 of them and sort of put them in preference order. That's a really hard tasting task, but there wasn't any consistent preference that came out of that particular one. Although again, that's a really hard tasting test to get somebody to do. So it would be hard to get good numbers on that. So when we sort of sum up then in our 2018 and Kirsty's 2018 work, we're really looking at, you know, that higher SO2 dose led to higher total sulfurs, but also led to sort of aging in a place that was much closer to that target of 0.5, but not hitting that target of 0.5 most of the time. We didn't look at the data today for the new barrels, but when we looked at the new barrels actually bound more SO2 than the neutral barrels did. And that did lead to some potential spoilage along the way. You can see that in the report. So I would say, just as a practical thing, when you're managing SO2, at least at the beginning, it is useful to take the SO2 number of your new barrels separate from your neutral barrels, because that evolution, at least initially, is a little different. And there's a few reasons for that. We'll have that in the newsletter and in the report. But again, delaying the SO2, we did get a lower total from that. Kirsty's impression was that those were fresher and had better fruit. And again, we were closer to the target most of the time. So Kirsty, with all of this, you still really, what was your take home? So after 2018, what did you take into 2019, and what additional questions did you have coming into 2019?
Yeah, so from 2018, I realized, I guess it really hit home the difference between new barrels and neutral or less, more neutral barrels in terms of SO2. But that really wasn't the question I wanted to ask. I came away from 2018 with the idea that, okay, I decided I want to have a bigger initial dose, and I want that dose to be delayed by 2 weeks. So I went into this experiment with the idea that the standard would be a high dose with a 2-week delay. However, I knew from what your analysis showed is that I never was at that 0.5 molecular consistently. So I thought, okay, well, maybe in order to get to that 0.5, maybe I just have to do a much bigger dose at the beginning. So I chose 75 and 100 for this year as those 2 dosage rates, but everything was added 2 weeks after malolactic was complete.
Okay. So we're looking much at the same questions as we did last year in terms of what does this mean for hitting the target? What does this mean for the overall chemistry of the wines? And what does that mean for the sensory? And again, this year it was the same question, but we still had 3 sets of barrels to look at. So Kirsty had 2 sets of barrels. Again, the barrels within the pair are comparable to one another. One that was in neutral barrels, 75 versus 100 with that delayed dose. One that was in some barrels that were new in 2018. So they're relatively new, but not brand new. And then one set that just came from fruit that came from a different vineyard. And again, just keeping in mind, all of this is happening after malolactic is complete. So the wine that goes into the first 2 sets of barrels, that's all the same wine. The wine that goes into the last set of barrels, that's the same wine. But again, we just wanted to see, is this, how consistent is any trend that we see happening, one vineyard versus the other, one set of barrels versus the other. So having 3 seemed to be a good thing to do, and Kirsty had the barrels to do that with. So thank you, Kirsty, for giving us 3 sets on that. So when we look at the data on this, again, all of this was done on the finished wine. So the chemistry of the grapes going in are not vitally important because we're not comparing vineyard to vineyard in this case. But I'm showing you this just to show you that this was done in Cabernet Sauvignon. So last year was Cabernet Franc, this year is Cabernet Sauvignon. But for Virginia, these are good chemistry numbers coming in. The fermentation went smoothly. The maceration time was pretty standard for Kirsty's winery, and malolactic completed in a reasonable time. So there wasn't anything about that gave us alarm bells in terms of like, maybe we need to disqualify this set of barrels. And again, the finished wine chemistry, we would expect the pH and the TA and the alcohols to be the same for the things that came from the same vineyard. I show you these numbers just to prove to you that indeed these are, and if there was anything different there, again, we would see some alarm bells. So now for the moment you've all been waiting for. So what you tasted was the Claim Vineyard neutral barrels, 75 and 100. So if you remember what your numbers were, if you've got your wines in front of you, this, depending on which group you were in, this tells you which one is the same and which ones are different. So I'll let you kind of look at these for just a minute. I will say when we've been doing these virtually, I've actually been doing them because usually there's enough time in between, but when I sat down to do mine today, I actually remembered what the pattern was for my group. So I had to disqualify my own sensory. So, but then I had my husband taste, and I might count his, because he's home today. So. Okay, so does anybody, if you need more time on this, please unmute yourself and tell me. Hopefully everybody got to their decoding. Okay, so let's go ahead and take a look at what this chemistry looks like. So I've put together the Claim Vineyard numbers on the top and the Piggott Vineyard numbers on the bottom. Just again, otherwise it was too many things in one graph at a time. But you can see that the initial dose of 100 did a pretty good job of keeping Kirsty above that 0.5 threshold for the majority of aging, both in the Piggott Vineyard and in the Claim Vineyard. In the Claim Vineyard, the neutral barrel with an addition that happened in January, she was able to get up into that 0.5 range. But in the Piggott Vineyard with that same addition, she was not able to get up there. So again, it does seem that higher dose is doing a better job. And in this case, you can see it does sort of come down over time. It's not like you're going to be adding 100 right here and then you're still going to be, you know, at a super high SO2 by the time you're trying to bottle. And another thing to be said here, Kirsty's bottling these wines, I think, next week. So just thinking about the progression that she needs to think about in terms of bottling targets. So again, it looks like the 100 did a better job of keeping Kirsty at that target, but with one addition in January, she was able to get to that target in the 75 as well. So, so then I just wanted to show what that meant for the free sulfurs and the total sulfurs. Sometimes when you see that really high molecular number, you're like, what kind of free am I at? In this case, that was really kind of a range. The highest free that she got to was about 45 parts. And again, that target was right around, I think it was like 27 or something like that was about what she would get for it to be at the target. And here, if we look at the difference in the totals, again, the high dose has higher totals, which makes sense. But again, it was the one that was actually at the target most of the time. So we have to keep that number in mind. But another question that we think about here in terms of both antioxidant and antimicrobial is how is that doing to control volatile acidity? That's our sort of our primary measure of spoilage over time. So we took a VI number in December right after these. So these had gone into barrel, I think, what, in November, Kirsty?
Yeah, maybe a bit sooner than that.
Yeah, it was somewhere in November. So we sort of gave them a little bit of time in barrel. We took a number. We sent these off to the service lab in December, and then we sent them off again in April. And I think what we can see here is we don't see big changes in volatile acidity over time. We do see differences in VA between the barrel groups. And I think that might have more to do with the barrels that you're putting them in. These 2018 barrels do have a fairly high volatile acidity, but when we track that back to last year, those were the same barrels that we saw some spoilage in. So that might just be a function of those barrels. But in this case, both the 75 and the 100 part adds were able to maintain, basically you're not getting a lot of accumulation of volatile acidity. And so in that case, you're controlling that pretty well. Kirsty, Melanie is asking, what's the SO2 at crush for these?
50.
50. And that's a pretty standard ad for you, right? For 50 at crush. Yeah. So the other thing that we're looking at is that we want to kind of take a look at is sort of our color, what's happening with our color and our phenolics. So are we seeing big differences there? In this case, we do see a little bit less color expression in the higher dose than the little bit lower dose. These are very small differences though. And I don't know about you guys, I couldn't really pick up I didn't perceive a color difference in the wines. Myself. And when we look, but again, when we look at our anthocyanin numbers, we actually kind of see the same thing we saw last year. The higher the dose, the more total anthocyanin you're seeing. But again, we don't really see big differences in polymeric versus polymeric anthocyanins in those two. So, you know, I think for you, Kirsty, since these are going in the bottle right now and they're probably going to be consumed within a year, you know, thinking about that longer term aging is a little bit different as well. But that's sort of what the target is for this wine. And so thinking about that management is a little bit different. So with all of that, though, we've invited all of you here today so that you can share with us what you think of these wines. So I'm going to go ahead and come back so that we can all see each other again, or I can see all of you. So having tasted these wines, first of all, maybe just do a show of hands. Who was able to tell the difference between the wines in the triangle test? And just keep your hands up for a minute because I have to go between screens. All right, there we go. Okay, not so many. So those of you that were able to tell the difference, what was different for you in the wines? What did you perceive to be different? You can unmute yourself and tell me what was different for the wines.
The higher addition ones, the very high ones, to me, the aromatics were much cleaner. The fruit was brighter. Even on the palate, the one that had a little bit lower of an addition, it kind of fell flat a little bit for me. So I really had a preference for the higher addition ones.
For
so that
me,
might be part of that sort of preserving preserving some of the fruit. I'm sorry, Daniel, you were going to say?
Sorry. For me, I got on the high edition. I had a grippier finish, more astringency on the finish.
Okay. And that would sort of go along with that idea that maybe we haven't had as much polymerization along the way. Okay. Other differences that those of you that saw a difference in the wines, what difference did you pick up?
I actually did notice a little bit of a difference in the color, and more stronger aromatics to it. And then, yeah, like Melanie was saying, a brighter fruit character to the higher one.
Okay. Any other differences between the two wines?
Joy, would you
Beth,
show the part again of the results? Because I know, I remember which one, I was in group 2.
Okay, let me get back to that slide and I'll just share real quick in case anybody else needs to see. I just have to find where I put it. Here we go. All right, let's see. Share the screen here, share. Okay. Can you see it, Joyce?
Yes, okay, now I can tell you what I felt. So for the very high ones, I felt they had more developed grape character, I think, and also a little bit, I definitely got the more stringent finish on both of them.
Okay.
Whereas the high one, the 906 in that case, I had notes that I had detected an herbal lighter palette.
Okay. Okay. And Beth, were you about to pipe in there when we went to the screen share?
Yeah, just that, so I was in the third group, so I only had one very high and then the other two were just regular high. I found it pretty hard to differentiate and I didn't see the color difference. But the very high, this was interesting, is that it really, I got fresh cranberry from it. So that fresh like aroma, I've never had a wine that had that much like cranberry. I don't mean like sour, like malic acid, but I just mean like smell. And so that was, I don't know, I just thought that was really cool about that one. So.
Okay. Yeah, I actually picked up cranberry in this wine as well. And it's sort of a fresh red fruit, but not like raspberry, but different.
Yeah. It just made me think of like Thanksgiving turkey and like this would be the perfect wine because just, yeah.
Because it would go with
There
it.
seemed to be certainly a difference in the mouthfeel. Kirsty, what was the oxygen management that you have for these wines? So post MLF, was there any oxygenation?
No
racking?
Yeah, no racking at all. Just post ML, it stays on those lees the whole time. There's no stirring and there's no, the only oxygen, I mean, obviously oxygen through the barrel and oxygen when I take off the bung, but other than that, nothing.
Right, okay. Yeah, it's interesting. There are definitely some structural differences and textural differences in the wines.
Yeah.
I'd be curious for those of you that found it more astringent. I mean, I guess it's a stylistic question, but for those of you, was that a positive or a negative for the astringency?
For me, you know, when talking about like structure, a Cabernet Sauvignon, for example, something that has that the structure of the high dose could be positive, but then in another varietal it might not be. So it's really hard to say if one is better than the other. Just that there seemed to be more, I don't really know how to put it, but a grippy finish.
Yeah, I found the same.
So Kirsty, for you, for your sort of stylistic goal for this wine, do you like that extra grippy or not?
So I got the difference right, but it was 10 times harder to get that difference today than it has been when I know exactly which wine is in which cup, which glass. So I think
I give you the coded samples.
Me too, because I think it shows how important it is to taste blind. The little difference I saw is actually, I see it as a positive, because if I saw a huge difference and perhaps in a negative way, I would be disinclined to add 100 parts. But after today, because I added SO2 once from the time that after malolactic until now, that in itself is enough to make me want to go with the higher that highest dose, that 100 parts 2 weeks after malolactic, because I know that all wines are different, but I've seen over the past, I feel like that higher dose is going to lead me to sleep better for longer periods of time. And that to me is worth it. And perhaps it's a little bit more astringent. I don't think it makes, I don't know. I'd be curious to see if I start doing this as a general way of managing red barrels, if I like the red wines that I'm making less. I'm not sure, but from a logistics and from a workflow point of view, this is pushing me to think about that 100-part edition over the 75-part edition.
Yeah. So how about those of you, the others of you, given what you've tasted today, what do you think about sort of going to that higher dose? Is it something you would consider, or is it something that you're like, that's just not in my ballpark? Who would consider sort of going higher in the dose? Maybe 100. This is the kind of thing that before I tasted this experiment, I would have been very scared of that high of a number. But I think to me, like seeing the actual number of what I'm aging at, how I'm not actually getting to the target, realizing that right in front of me, I think that makes me think differently about it. So, okay. And so I guess the other question, yeah, so those of you that are willing to go there, do you have thoughts to add to that, or just you feel like it's not scary and you're ready to go? The one caveat I did think about, and this might just be in my own particular experience, but for whatever reason, the Chambourcin that I used to work with, Chambourcin holds on, to me, it always would just sort of hold on to its sulfur forever and ever. So like whatever sulfur you added, it seemed like you got it back. And that might actually, there are a lot of questions about why that is. But I would say that for me, like I wouldn't want to go to this management strategy for something like Chambourcin, because it seems like it's just going to hold on to that sulfur. You're kind of banking on the fact that you're going to be drifting down over time. So it might be the kind of thing that you do try. Again, this experiment is a great experiment to set up in your winery, because almost everybody has a couple of barrels of something. So you can do that side by side. You're just really committing to doing a little bit more fine-grained SO2 monitoring. But if it's something you are thinking about, I would highly encourage that you do find a couple of barrels of the same thing, that the barrels themselves are as comparable as you can, and just sort of try this on your own. This is the one lab test that almost everybody is running. So, okay, so any other sort of concluding remarks about this experiment before I move into overall conclusions from this year? Anything else that anybody wants to say about SO2 management?
I think, just as a sidebar, I think Pat Howe wrote a publication that helps to define the parameters as to this SO2 binding on the anthocyanin and how much free is actually created when you're running a Ripper or a AO analysis.
Great, I will look that up. Is that recent, Bruce? That must be in the last couple of years then?
It was about less than a year ago. Less than a year ago.
I think it's 2016.
Okay.
ADEV, yeah.
Okay.
I can't remember if there's a follow-up publication from her or somebody else, but basically doing measurement of free SO2 and looking at
they're looking at this pigment, the interference from the fact that the AO would give you a false free level.
Right. Yeah, I saw the paper that it said that it would, but it didn't seem like there was a good correlation. So that's good to know that there is a way to kind of at least start to look at that. So I'll look that up. If I have trouble finding it, I'll ask either Bruce or Beth. I'll ask one of you guys to shoot it to me. And I'll make sure to roll that out as part of the WRE information on this as well. So thank you guys both for bringing that up.